This is a brief tutorial from Mr. Jones on using Excel to graph data, experimental data in which you have an independent variable and one or more dependent variables. Now, different sources will refer to this sometimes as a line graph. In Excel, it's what's known as a scatter plot. So I'm going to do a few examples for you. So the first one is just going to be a simple function. Actually, um, this isn't going to be experimental data at all. I'm just going to use a function that you'll recognize to show you how to set up a scatter plot. So I'm using some functionality of autofilling and inserting formulas in Excel. You don't have to do this. You could have typed in 1 through 16 without doing what I just did, but I have fancy Excel skills. And so in this case, I'm going to make the dependent variable the square of the independent variable. So again, I can use a formula to do that. Equals a2 to the power of 2. And I can use the autofill. Again, you don't need to know how to do these things. You could type in all these numbers independently. I'm just using some shortcuts to get those numbers in quickly. Okay, once you have, when you do a scatter plot in Excel, it's always going to consider the leftmost column to be the independent variable, and we'll plot that on the x-axis. And any columns to the right of that are going to be considered dependent variables and be plotted on the y-axis. So I'm going to highlight both of those. I'm now going to go to Insert, Charts, and this is what the scatter plot is right here. So I'm going to click on the scatter plot, and because this is a well-behaved mathematical function, I'm actually going to click on the little thing that has curved lines in it, because then it's going to actually fit a curved curve to this that follows the mathematical function. So I just click on that, and I've got that. Now, there are more things I can do to this. So, for example, I'm going to call this y equals x, and I got to go in here, back here to get a superscript. Y equals x squared. Okay. Now, if I click on the plot, I can hit this plus sign. Another way to get to the same thing is to go in here in the Design tab and click on Add Chart Elements. Okay. I'm going to add axis titles. So I can do it here or I can do it here. Add axis titles. Okay. And so now I'm going to call that axis X, and you'll see that it is appearing up here. And if I hit a return, it just made that X. I'm going to call this axis Y, and you'll see now it says Y. The other cool thing I can do here is format axis title, and right there it allows me to rotate it so that it's horizontal, so you can see why. Okay. Now that I've done that, I can go ahead and click on print. And so if the teacher had asked you to print this out, there you go. You can print it just like that. Some other things it allows you to do in quick layout is to actually have it will give you, so if I click on that, it actually gives me the x and y coordinate for each point. So for example, that's 12, 144, 13, 169, etc. I'm just going to go back to what I originally had, that's not exactly what I originally had, but oh well. Okay, so let me show you one more quick little trick here. Because I was using formulas, I can actually change this now. Instead of making it y is equal to x squared, I can make it y is equal to a 1 over a2. I can make it, I'm just going to make this the reciprocal. So instead of making y x squared, I'm going to make y 1 over x. You notice when I did that, it actually automatically redid the chart to now give me a new plot. And if I wanted to, I could print that. Okay, so that's the simple. That's just one simple example. Suppose you actually have two dependent variables for your independent variable. I've gone ahead and plotted and just made 3 columns here. So my independent variable is just going to be x. I've numbered it 1 through 10. Now in this next one, I've got x squared, and in the next column, I've got x cubed. And so now I'm going to highlight all 3 columns. Again, I'm going to insert a chart scatter plot. Again, because these are well-behaved mathematical functions, I'll use this curved line version. Okay, and now it gives me this. Again, I can go into things like change colors, and I can make these. I can kind of mess around and make the colors of my my lines anything I want to make them. If I add axis titles, I'm going to call this X. I'm going to call this Y. Notice again, when I type the Y, it appears up here, but when I hit return, it now appears here. Again, if I right click on this, I can format the axis title. I can rotate it so that it's horizontal. I can call this exponential functions of x. It's now called exponential functions of x. And the green one is x squared, and the blue one is x cubed because I had written these. Up here. Okay. Now, what if you have data that's not some mathematical function like what we just did? Well, here I have gone ahead and generated some data to pretend I am counting the number of cats and dogs in some area over a course of days. So my independent variable is going to be day number. I've numbered it 1 through 10. And then the dependent variable is the number of cats, and then the second dependent variable is the number of dogs. And I've sort of treated this as a predator-prey relationship. So the cats here are sort of multiplying exponentially, and then dogs appear, and as dogs appear, they start eating the cats, and so the cat population goes down as the dog population goes up. But then because the dogs ran out of cats to eat, their population crashes, and the cat population goes back up again. So I am going to take all 3 of these, and I'm going to insert a scatter plot, but this time, instead of using a curve, I'm going to use this one, which gives me straight lines connecting the dots. Okay, and so this gives you now a good idea that here the cats, their population increases exponentially until the dogs start to appear, and then the dogs start eating the cats, and then when the cat population crashes, then the dog population crashes, and now the cats start to recover again. Again, I can call this cats versus dogs by day. I can put in axis titles. So this is day. This is a number of animals. Animals. Oops, I misspelled that. Animals. And because now if I were to try and flip this horizontally, it would take up too much space. I'm just going to leave it like that. Again, if I wanted to, I can change the colors of things. I can do a lot of different things like that. And if I now go to File and Print, I can print this out on the library copier. Okay. One more thing I want to show you here, and that is here's some data, and I have to tip my hat to this for this data to former AP chemistry student Hans Hohmeister for a laboratory experiment he did. I've actually messed with his data. He actually had much nicer data than what you'll see here, but I had to mess it up on purpose to show you the purpose of using what's called a trend line. Okay. So this is supposed to be a linear relationship. That is that the heat in joules is supposed to go up in a constant linear fashion relative to the moles of reaction. If I go in here and insert that chart is if I'm going to insert that chart, you'll notice that that's not a straight line. It is supposed to be a straight line relationship, but because again I've been messing with Hans's data, you don't get a straight line there. So let me actually undo that, and instead of using a scatter plot in which all the points are connected by lines, I'm going to insert a scatter plot that just has the points without the lines connecting it. And now I want to know, okay, what actually is the formula for a straight line that more or less goes through all these points? Because what I want to know is what is the actual linear relationship that they are supposed to have. And so I go into the add again, and now I do what's called adding a trend line. And you can see now it has put a line in that doesn't really touch any of the points, except it does touch this one. That is the straight line relationship between these 4 points. And now if I want to know what the slope of that line is, because I'm trying to figure out what that, about that line, I can right click on the trend line, format trend line, display equation on chart, and now it gives me the equation for that in the form of y equals mx plus b. I can again put in my axis titles. This is moles of reaction, and this is heat in joules. And I can print it. I could also copy it. Let's get real fancy. I could also take the whole thing, copy it, and say paste it into a PowerPoint. Let me get rid of, and so if I wanted to, I got to get, let me back up. First, I'm going to delete what's there. Now I'm going to paste it in, and now I can make that bigger. And I could, if I was making a presentation for some teacher, oops, didn't mean to do that. If I was making a presentation for some teacher, I could paste it into a PowerPoint or paste it into a Word document or something like that. Okay, I hope that was helpful to you in creating graphs in Excel of instances in which you have independent and dependent variables. Bye-bye.